The set of all points that are equidistant from some fixed line. That fixed line is going to be what we call the directrix. And some fixed point, and we'll call that point the focus. All right, so, it did not show up, did it, when I wrote focus? Let me see if I stop sharing this, if it fixes it. There it goes. Okay. All right, this point that we are measuring them from is going to be the vertex. And that's going to be the midpoint of the segment from the focus that's perpendicular to the directrix. Okay, and we also can see what's going to be called the axis of symmetry. And this is just the line that goes right through your focus and your vertex and your directrix as well. All right, so there are two forms of this equation. What you might be expecting to see, like if you were talking about a regular parabola, right? And in this case would be the equation y equals 1 over 4p times x minus h squared plus k, where we know h and k to be the vertex, right? Your h is going to be how far to the left or right your vertex has shifted. Your k is how far up or down your vertex has shifted, right? And then that value out in front is typically like your stretch or your compression, right? Okay, if your figure has been flipped over on its side, so it looks like a horizontal version of the original, your x's and your y's switch places. So you would have the equation x is equal to 1 over 4p. But this part is going to change a little bit too, because remember your y is the vertical shift, right? Which comes from your k value. So in the parenthesis, you'll have y minus k squared with your plus h out here on the end. All right? So in these pictures, this point right here would be that point that they're referring to as the focus. We know that this point right here is the vertex, right? And this line that's right here below our figure that I just drew over in red, that is our directrix. Okay, and what we said earlier is that your vertex should be right in between them, right? That those two things are equal distance from your vertex. So we're saying the distance from here to here is the same as the distance from here to here. Okay, so those should be congruent. Okay, same would be true over here. We know that this piece right here would still be our vertex. The point inside of it here would be our focus. And because our figure is turned on its side, its directrix is also turned on its side. So now this would be your directrix. Okay, and then it goes ahead to reiterate that same thing down here, that the distance from the vertex to your focus should be the same as your vertex to the directrix. And then they have a little figure drawn below here to show you that the measurements from here to here would be congruent, as would be from the focus to any point on your actual graph. So if you notice, they denoted the length of this section right here and this section right here from directrix to vertex and vertex to focus using the letter P. That's why in our equation, we have 1/4 p right here. P is going to be the measure of how far it is from your vertex to your focus, or from your vertex to your directrix. All right, so first here it says we're just going to rewrite these equations in standard form. Okay, so standard form is either this or this, depending on if our graph is going to be vertical or horizontal. So remember, our equation should end up having a square in it, right? Not a square root. So that tells you what you're trying to solve for. So I would not want to get x by itself, because to do that, I would have to take a square root, and then we don't have a square anymore. So I must be trying to get the y by itself. So what would we do to get y by itself? Right. So I'd multiply both sides by 2. And now I've got y equals 2x squared, right? All right, for example 2, again, we don't want to get rid of the square. So what letter do I want to try and get by itself on example 2? The x, right? Okay, so if my goal is to get the 2x by itself, I might keep it where it is and move the 3y squared to the other side. So now we got this. Where do I go from here? Right. So we'd end up with y equals negative 3y squared, x equals negative 3y squared over 2. All right. Okay, you guys try example 3 and 4. Remember, you don't want to get rid of the square, so solve for the other variable that does not have the square. So again, we're just trying to solve for the variable that does not have the square for examples 3 and 4.
Just leave it. Don't try to multiply them. Just because you want to keep the square. You see how all of these.
Remember, when we're done, it should look something like these two forms that we wrote up here. So if you have a quantity squared, you don't need to actually square it, right? Because the formula has it written as a quantity squared.
In these questions, are we going to have to like solve for p at any point?
Yes.
Okay.
Mm-hmm. Okay, on example 3, which variable were we solving for? Y. Okay, so right now we can't do much with y because it's a quantity being multiplied by 20. So the first thing we probably did was what? Probably divide by 20 or distribute so that you can then move something over. Same thing happens either way. Okay, if I divided by 20, then I would have 1 over 20 times x minus 3 quantity squared equals y plus 1, right? Okay? And then from here, I would move something over, right? If I distribute it, I'm moving a 20 over. If I just divide it, I'm just moving a 1 over, right? So then I'd have 1 over 20 times x minus 3 quantity squared, minus 1 equals y, right? If I had it distributed, now I'd go through and divide everything by 20, and I'd still end up with this term out in front, and this would become the negative 1. All right, perfect. All right, and then that meant for example number 4, we were trying to get the x by itself then, right? So kind of the same process. we would probably want to divide first, right? So now we would have 1/12 times y minus 3 quantity squared equals x minus 2. And then to get x by itself, I'd simply add the 2, right? So I'd have 1/12 y minus 3 quantity squared plus 2 equals x. So now on all of these, we would be able to determine what h and k are, right? Because of whatever is written in the equation. Here, there is no parenthesis, right? And there is nothing out here on the end, so h and k must be 0, 0, right? Same for example 2. But on example 3, here's my h, here's my k, right? Now, since the other one we solved for x, remember in here would be my k, out here would be my h, right? Okay. All right, so now that we know how to get them in the correct form, turn it over onto the next page. Okay, on these first 3 examples, they just want us to identify that if we were to go ahead and actually solve for whichever particular variable that we need to, would we be discussing having a vertical or horizontal graph? So remember, if you look back on the front page, horizontal is when it looks like this and when we solved for x, right? Vertical is when we solved for y. So on example number 5, would I be solving for x or y? Y, so that means this one would be vertical, right? Okay, on example 6, would we solve for x or y? X, so this one would be right. And what about on example 7? Vertical, right, because we'd solve for y. All right, so now we can kind of predict which type of graph we should have. In the next section, they give you some information like the vertex, which remember is your h and k. So here they gave me h and k. They also gave me some a value. Remember, this is what goes out in front of your equation. And then they also told you if it is vertical or horizontal, right? So on example 8, they said it was vertical. That means y equals, right? They told us that that value out in front, your stretch or compression, in this case was -1/2. And then they gave us h and k. Well, since it's y equals an equation, h is going to go inside the parentheses with x. And remember, whatever is in the parentheses is opposite of what we think, right? So it's going to actually be x plus 2, right? Quantity squared. And then we put our value k on the end. So we'd have 5 out there on the ends, okay? You guys try examples 9, 10, and 11. You're just writing the equations based on the information that they provided for you. So they gave you h and k. They gave you your a value for out front. And they also told you if it was vertical or horizontal, which tells you is it x equals or y equals some equation. All right, so number 9 was pretty easy because it was exactly like number 8. They gave us h and k. they gave us this A value, and again, they said it was vertical, right? So we knew it was y equals some equation. Out in front of the equation, they said our A value was 2. And what did we put in the parentheses for this one?
Y plus 1.
X, yes, So we'd have x, and then it's actually a positive 1 here, so we would put a minus 1, perfect. And then we would have that minus 3 out there on the end, right? Okay, now number 10 and 11, these ones are going to have the h and k values switched, right? Because these ones said they were horizontal, right? Okay, so this is still h and k, but since it's horizontal, I'm going to have x equals our A value, which was -3. Okay, but remember, when it's y inside of there, y is vertical, which goes with k, right? So this time I'm going to put k in that parenthesis. So I would have y plus 1, because it's still opposites of what we think since it's in the parenthesis, quantity squared. And then we'd have our plus 6 on the end, right? Okay. All right, and then number 11 was also a horizontal. So what was that equation? Okay. So we have our, y plus 7 quantity squared minus 5. All right. Okay. All right. So here on these examples, it says you need to figure out where the focus, the vertex, and the directrix would be for these equations. And then you need to plot those 3 things and draw a sketch of the graph. Okay, well remember, this part and this part are my h and k, right? It was y equals, so h is the one in the parentheses. So what is the coordinate point of my vertex? 3, -1. Okay. Now remember, your focus and your directrix should be equal distances from this point, right? And remember, the distance away from that point comes from this part right here, right? 1/4p. Apparently, in this case, equals 1/12. And so I'm just trying to figure out what P is, because remember on the front page we said P was the distance between the vertex and the focus and the vertex and the directrix. So here you could just cross multiply with what we have set up here. So I'd have 4P equals 12, so P must be 3, right? Okay, so this one was a vertical, right? If we look at the fact that it's y equals. So that means that my focus should be 3 points above this one, right? Sorry, that's the x value. 3 points above this one. And then my directrix should be 3 points below, right? If you look back at the original graph here, the focus is above it, while the directrix is that amount below it, right? P values are the distance. So, if I move 3 places up from -1, where would I be at? Okay, so my focus is at the coordinate point 3, 2. Okay, so remember your focus is a point, but remember your directrix is a line, right? So, I'm going to go 3 places down from -1, which would put me at -4, right? And remember, it's a horizontal line. So that would be the equation y equals -4. Okay? And those are the only 3 things that you need to graph this. So at -4, we have our horizontal line, our directrix. And our vertex is at +3, -1. And our focus is at 3, 2. And then we know our graph is going to look something like this. All right. Okay, let's do another one. So for number 13, remember H and K come from here and here, but on this example it was X equals, right? So remember that's going to make this part K and this part H, right? So this vertex is the coordinate point . Where's the vertex?
3, 5.
3, 5. All right. Okay. And how do we find P? What do we do? Set our A value equal to 1 over 4P. Right. Okay, something I want to remind you guys of. The negative does what to our equation? Flips it, right, reflects it. So I don't need to put that part in the proportion that I set up. I just need the number value. Because we know the negative isn't the actual A value, it's just telling us that our graph is reflected, okay? So, again, I cross multiply. I got 4P equals 4. In other words, P equals 1. Perfect. Okay. Now, in this case, look back at the original graph. Your focus is normally to the right, while your directrix is normally to the left. But you guys said our graph had been flipped, reflected. So that means my graph actually would go this way, which means this would be my focus, and over here would be my directrix, right? So to find my focus, I'm going to move P places to the left. Okay, so if I move P places to the left from 3, I would be at 2, 5. And if I move P places to the right from 3, then I would be at 4. Now remember, your directrix is a line, not a point. And this time it's a vertical line, so it would be the line x equals 4, right? So on my graph, I've got my directrix over here at x equals 4. I've got my vertex at 3, 5, and my focus at 2, 5. So our graph looks something like this. So remember, guys, if it has that negative in front, it flips your graph around. If it was vertical, it would just make it upside down, right? So that would make your focus and directrix switch places. All right. Flip it over onto the next page. All right, on this one, instead of giving you the equation, they gave you the coordinate for the focus and the equation of the directrix. We're going to have to figure out what the equation would be, right? So that we can say where our vertex would be. Okay, well, let's go ahead and draw these two things on our graph. So apparently we have the directrix up here at y equals 5. And we have the focus at the point -3, +1. Well, the vertex is supposed to be in between them, right? Well, what's right in the middle of 5 and 1? 3. So I'm going to know my vertex has to be right here, which would be at the coordinate point -3, +3, right? Okay, well, because my directrix is a horizontal line, that tells us we have a vertical graph, right? So we already know it's going to look something like this. So that means this truly is H, this truly is K, and it's going to be a y equals equation, right? So we're going to have y equals, okay, now in this case, our 1 over 4p what was our distance P? 2. So this would be 1 over 4 times 2, which gives us 1/8. And was our graph reflected? So I would also need to stick a negative in front, right? Okay. And then you guys said that our h value was -3. So I'm going to have x plus 3 quantity squared. And then our k value was +3. So we'll have a +3 on the end there. Okay. So now we know how to do it, whether they give us the equation or whether they just give us a couple pieces of information. Okay? Now, what they might do is instead of giving it to you in standard form, they might give it to you in something that looks like this. We want it to be in standard form where it has that quantity squared so that you can see what h and k are, right? So they tell us in order to get it in standard form, we have to complete the square. Guys. So I know that you did this in Algebra 2, but it might have been a little bit. So let's go over this first one together. When you're completing the square, you can either move everything to the other side that you're not going to put in that parenthesis, or you can just leave it on the outside of your parenthesis on that side. Either way, you'll get the same outcome. So I'll do one both ways. So on the first one, we're going to have to keep this part in the parenthesis, okay? So we keep the term that has the square in it, and we keep the linear term, right? And then we always put plus blank. And we're trying to figure out what goes in that blank. All right, a lot of times we'll just go ahead and move everything else to the other side of the equation. So I'll do that on this one. So I'd move the x over by adding and the 1 over by subtracting, right? Okay. Now, before we can decide what we're going to put here, you need your lead coefficient to be a 1. Right now it's a 3, so we want to take out our greatest common factor. So I can rewrite this as 3 times y squared plus 4y plus blank equals x minus 1. All right? Okay. So remember, whenever you're completing the square, you look at this number right here and you half it. So half of 4 would be 2, right? And then that's the value I put here and I square it. But if I do that to one side of the equation, I'd need that on the other side as well, right? So I'd put plus that 2 squared. But don't forget, that 2 squared has this 3 out in front of it that it would be multiplied by. So I'm going to put it in a parenthesis with a 3 in front of it over here as well. Okay, the whole reason you do that is because now this is something that we can factor, right? And this is the same thing as a 4 here, right? So I could rewrite this as y plus 2 quantity squared now. Okay, don't forget, we do still have that 3 out in front. And over here, we've got x minus 1. And if I were to simplify this part right here, that would be 12, right? 2 squared would be 4. 4 times 3 is 12. All right, and then these two are like terms, so I could actually go ahead and combine them. So I'd really have x plus 11 over here, right? And it would look like in this particular case, we'd be solving for x because we don't want to get rid of the square that's with the y term. So to solve for x, all I would have to do is move over the 11, right? So we'd end up with x equals 3 times y plus 2 quantity squared minus 11. And we move it back over. Okay. All right. For part B, again, we're going to keep this part, the linear term and the square term, on that side. I am going to rearrange them so that the leading term or the first term is the one with the square. So it would be negative x squared plus 4x. Remember, this is where you would put your plus blank, right? All right, so this is what I was talking about earlier. Some people move everything over, so everything left they would move over. But you only have to move the term with the y in it over. So if you wanted to, you could keep your -1 over here and just move the 3y over, or you can do like what we did on the example before and move it all over. It works out the same way, whichever method you prefer. I don't know which way you learned it in Algebra 2, so I'll do one both ways. Okay, so again, I don't want my lead term to be anything but a 1 in front, so I'm going to factor out a negative, okay? So I'm going to have a negative out in front that would become a positive x squared, a negative 4x plus blank, right? And then I'd still have that -1 equals 3y over here. Okay? So remember, I look at this term right here, which is -4, and I half it, right? So when I half it, I get -2, and that's what I come put in the blank here, is -2 squared. Or you could just write it as 4, right? Okay. So if I were to write this in factored form, it'd be x minus 2 quantity squared. Still has that negative lead coefficient that we pulled out in front. And then if you kept your -1, it's still over here on this side, equals 3y. But remember, if we did it to one side, I'd have to do it over here as well, right? So I would have put that -2 squared on this side as well, meaning I'd have, oh wait, sorry, that's a negative on the outside too because of the negative we pulled out. So a -2 squared. So while I square the -2, it does become 4, but that coefficient that we pulled from the other side keeps it being a -4, right? And then I'm just trying to solve for y this time. So I'd move the 4 over by adding it. So then I'd have negative x minus 2 quantity squared. If I add 4, I have plus 3 equals 3y, right? And then I'd have to divide everything by 3, right? So I'd end up with y equals, this first term doesn't have a 3 I can cancel out, so I'm just going to make that dividing by 3 part of my a value. So I'll have a -1/3 in front, x minus 2 quantity squared. But here, 3 divided by 3 would make this just a 1 on the end. Okay. All right. Okay. Now, for the next two, they already have it drawn. We're going to come up with the values of the vertex, focus, directrix, the axis of symmetry, and then be able to write the equation. So for number 16, where is that vertex located? 3, 2. Okay. Where is the focus? 3, 1. And the directrix? So remember, it's a line, right? So it'll be the line y equals 3. Okay. Now your axis of symmetry, guys, remember that's where you could divide your graph in half. And it should be perpendicular to your directrix. So that's going to be, in this case, a vertical line, right? So it would just be the equation x equals 3, right? Okay, so now that I have all this information, I should be able to write the equation. Now, remember, 1 over 4p would be our stretch or our compression. And because my vertex was at 3, 2 and my focus was at 3, 1, what must our p-value be? 1. So that would just be 1 over 4, right? So my equation is a y equals equation, right? Has it been reflected? Yes. So it would be a negative 1/4, right? And then I would have x with our h value in there, which was 3. So I'd put minus 3, quantity squared. And then I'm going to put my k value out there on the end. And remember, h and k comes from your vertex. Okay? All right, let's do another one. On number 17, where is the vertex? Negative 4, 2. All right, and where is our focus? 0, 2. And what's the equation for the line of our directrix? X equals negative 8. Very good. Okay. And then your axis of symmetry, in this case, is a horizontal line, right? Because it's flipped on its side. So that's this line right here. What's the equation of that line? Very good. Okay. So now we're going to write the equation. The only thing I still need to figure out is that a value out in front. Again, remember that comes from 1 over 4p. Well, if we look at our vertex and our focus, what is the p value? What's the difference there, or the distance? 4. So p must be 4. So I'd have 1 over 4 times 4, which is just 1 over 16. Very good. Is this one reflected? No. So no need to put a negative in front. Now it is x equals equation because it's horizontal, right? So that means that the k value is going to go in the parentheses. So I'm going to have y minus 2 quantity squared, and then your h goes out there on the end. So you'll have your minus 4 out there. All right. Okay.